Okay. All right. Now let's start recording. So this technology is very nice. This is my favorite, one of my favorite programs, and it's cloud-based. So you do not have to install anything on your own computer. All you need is a web browser. So you just need a web browser, and everybody, if you have a camera, or just turn it off, so kind of can see your face. Have you registered multi-sim live? Yeah, to do today's lab, we need to register multi-sim live. So today I will have 5 little circuits to demonstrate. Let me turn my let me start sharing my web browser. So I think everybody saw my web browser, right? Okay. It became so slow. I have to move slowly. This technology is great, but you need a new computer. Let me stop sharing first. It's so slow. It's not moving. I'll stop it first. What is slow me down? So I have to remove some of the programs. Okay. It's so slow. Well, before the class started, it's pretty good. Let's restart. So I will open up my browser. All you need to do is Google. Let me start sharing. All right. Now we are talking. I hope we are talking right now. I just minimize my computer load. Hopefully, I will get smoother. So everybody saw my screen, right? So I will go to here, go to, oh, I need to log in, I guess. Did I log in? Yeah, log in. So I will log in. So it's a free account. Everybody can register for a free account. And those are the 5 circuits I'm going to show. So I will start it with the first one. Where the first one? First one is here. Okay. So if you remember, on Monday, we covered the 3 different types of circuits, right? Anybody remember 3? 3 circuits? I will open the textbook. This technology. Well, anyway, I will not open textbook. The 3 circuits, the first one is called voltage divider. You remember, right? Voltage divider. The second one is called bridge. What is bridge? A 2 voltage divider. The third one is called filters. So this is the first one I'm going to demo. So this will be open. I will open this circuit. So when I'm opening circuit, what you will see here is a simulation windows. I will have it half and half. You can go here, have your circuit complete screen, or you can split it half and half. That's what I preferred, half and half. So suppose this is actually a voltage divider. Actually, it's the identical circuit for volume control. So the green one is the input volume, the green one, green. The blue one is your output volume. That's the volume to your speaker. So what happens if I want to change volume? Right now, the volume is 50%, right? 50%. So I turn on the simulation. Turn on my simulation. And if you look at my screen, I need to change this to negative 2 to positive 2. So now I have a nice input volume. The output volume is 50% of my input volume. So what about I want to change volume? All I need to do is do it here. So look at the volume change. See the volume change? If I change the resistance, the volume will change. On the opposite side, that means I will reduce my volume to the speaker. What if I want to increase my volume to the speaker? I just move on the opposite direction. Now it's maximum volume. Maximum. Okay. So I can change my volume up and down just by a voltage divider. So this will be my first demo. Any comments? Let me see your comments, guys. This computer doesn't work as I want it to work. So if we do not have any comments, I will move on to the next one. Next one will be a bridge. Next one will be bridge. So I will go to here, go to my circuits. I will turn it off. My circuit. All right. I will save my previous one. What? Tim? We are isolated. I cannot give you virus through webcam.
Well, I'm at school right now.
Okay. All right. Let me see my second demo. The second demo will be a bridge. The second demo is right here. I really need a new computer. So what exactly is the bridge? Anybody remember? Bridge is a 2 voltage divider. So divider 1, divider 2. We have 2 dividers. And what happens if the bridge is balanced? Right now, the bridge is balanced. So if the bridge is balanced, the green voltage equal to the blue voltage. So if you look at here, on the simulation side, so I will readjust a little bit. So on the simulation side, you see they are all 3 volts. They are perfectly balanced. So if they are balanced, voltage here is 3, the voltage on the other side is 3, the voltage difference will be 0 between the green and the blue. So if you have a meter, you measure across these two, the voltage will be 0. So let's suppose, well, this guy right here will be our sensor. So that's a temperature sensor. So as temperature goes up and down, my sensor's resistance will go up and down. Right now it's 3000. So 3000, the bridge is perfectly balanced. What if I will increase and decrease my sensor resistance? So I will increase sensor resistance. What did you see? What did you see? The blue voltage goes up, right? Right now, the blue voltage is almost 4.029. So now the blue voltage is much higher than the green. So what's the difference? The voltage difference will be 1. So now the output of this bridge will be 1 volts because the output is the difference between the blue and the green. Right now, the difference between the blue and the green is 1. So the output of my bridge will be 1. That is if temperature increase. What happens if temperature decrease? If temperature decrease, the resistance of this sensor will gradually goes down. When the resistance of sensor gradually goes down, right now it's 3.2 K. What's the difference right now? The difference is 0.15, right? Because the blue voltage is 3.15, the green voltage is 3, so the output of this bridge right now is 0.14. So if the temperature keep dropping, dropping, now it's perfectly balanced. Now it's 0 again. So what if the temperature keep dropping? So if temperature keep dropping, now the blue voltage is below 3. Now the blue voltage is below 3. What is the blue voltage? Right now it's 1.9. So what the difference is again -1. So now the output for this bridge will be -1. So that's how a bridge works. A bridge is used to convert the sensor's resistance variation into the voltage variation. In this case, I just demoed the voltage as temperature drops, the voltage goes from +1 all the way to 0, all the way to right now -1. -1. Right now the voltage output is -1. So that will be my second demo. I'm recording all this. If you cannot do the lab right now after I finish the demo, you can always do it after class. Watch my recording and then do your own simulations. Of course, before you do any simulation, you need to build the circuits. How do you build the circuits? Let me do a demo. So you need to build your own circuits. All you see here is a new circuit. So now you have a brand new workspace, empty. And when you want to build circuit, all you need is drag and drop. For example, I need a battery. Come on, battery. I need a resistor. Okay, resistor. And then I need to connect them together. That's how I connect them together. And I need a ground. Okay. Okay. That's how you build a circuit. You can build, in this free version, you are limited to 25 components. And fortunately, our lab exercises are all simple. So it's good, no problem. After this, you can just save it. Save as, I will say my new circuit. I will say this is a demo. So now, if you go to my circuit, you have a demo. That demo is created 0 minutes ago. So 0 minutes ago, I created this demo circuit. So you can create as many circuits as you wanted in the cloud. Okay, any comments? Anybody want to say something?
How do we go back to look at our other file?
You go back, look, your previous circuits?
Yes.
You go to my circuits. You need to log in. First, you need to log in, and then you go to my circuits. You go to the upper left corner.
Oh, I see.
Excellent. Anybody else have questions? Let's move on to our third demo. Third demo will be this guy I have over here. That will be our third demo. Yeah, my computer is almost 10 years old. Really slow. Sorry, guys. All right. The third demo will be a low-pass filter. So this filter, if you remember, what is a low-pass? It will allow lower frequencies to pass through. It will reject higher frequencies. So let's see low pass. Well, you didn't see anything here, so you need to adjust your oscilloscope. So I'm going here. I see the positive will be 3, minimum will be -3. Maybe -2. The maximum will be 2. So now I adjusted this. What did you see? You see a signal getting stronger and smaller and bigger and smaller and bigger, right? But if you look closer, when it gets smaller, it has more cycles. That means frequency is high. So this is where the output is. So the output frequency goes up. The output gets smaller. When the frequency is lower, the output is bigger. That's what a low pass means. So this is a low pass filter. And that demos how a low pass works. Low frequency signal can pass through more. The high frequency signals pass less. So more low frequency gets through. Less higher frequency signal gets through. So anybody have questions about this demo? Low pass.
So, hold on, can you do that a little slower?
You want it slower, right? Right now, it's 2 seconds from low to high, 2 seconds.
Okay.
Yeah, we can do slower. Good question. Let's do slower. Is that slow enough for you?
Yeah.
Okay, thank you. The power supply is a FM signal, FM. Right here, that's your power supply. FM voltage, FM voltage. So when you are reproducing this lab exercise, that power supply, you choose FM voltage. All right, if we do not have questions, let's move on to our next one. Next one. My circuit. So go to my circuit. That will be the high pass filter. So the next demo will be high pass. So high pass and the same power supply. We switch positions for the capacitor and the resistors. So let's see what happens. High pass. Again, the first thing you want to do is about this oscillator. So you need to make that oscillator. That's something I want to improve. You always need to do something on the oscillator. -6, +6. All right, now we are talking. So this is a high pass. See the difference? The high frequency signals are stronger. The low frequencies are small. The input strength is identical. So what we saw here is output. The input is identical. Input strength is consistent. So we have the same low strength, but the output is different because the filter. Any comments? You want to slow it down, right? Let's slow down a little bit. Yeah. Any comment on this high pass? You see the high frequency go right through. The low frequency is almost zero, which is. So if we do not have questions, I will move on to next one, the last one. The last one is last one is called notch filter. Notch filter. Did you remember what is a notch filter? Notch filter means low frequencies can pass, high frequencies can pass. The frequency in the middle will not pass. So in this case, it's 400 Hertz. So the frequencies below 400 Hertz can go through. The frequencies above 400 Hertz can go through. The only frequency at 400 Hertz that will be rejected. So this is a notch. A notch filter has more components. In this case, we are using 3 resistors, 3 capacitors. So that's a notch. Let's turn on the demo. Did you see? When the frequency is really low, the signal gets stronger. When the frequency is really high, it gets stronger. But right in the middle, the signal are weak. That's what the filter does. So is there any questions about this one?
So how exactly do you get that graph to show the sine wave? I'm just a little lost on that.
All right, excellent question. Let's see. All you need is put one of those. Yeah, let me stop it first. All you need is get one of this, get voltage, and drag
That's right.
drag it here, and attach the wire. You're done. And now,
Okay.
if I restart my evaluation, you will see two traces. One is green, one is blue. The blue is I added the one I just added.
Well, I'll have to try that again. I was messing around with that a little bit here, and it didn't seem to work right away.
Okay. Yeah, it's always that's the only way to learn. Mess around.
That's true.
All right. The blue one is my inputs. The green one is my outputs. You see the blue one is the strength is consistent, never changed. The blue one strength is constant. The only thing changes is the green one, which is the output, my output. When it's low frequency, the green gets bigger. In the middle, the green gets smaller. When high frequency, the green gets bigger again. So it's a little trap. It will prevent the frequencies in the middle to go through. Of course, this one doesn't work very well. It's not a good trap. If you saw the performance, it needs a lot of improvement. There are ways to improve it. This is just the basic concept. This is the simplest one. What I want you guys to do next, if you want to do it now, start working from the lab 1. I will be here to help you if you have questions. Otherwise, you just watch the video, watch my recording. I will upload it, and you will reproduce it. Once you finish reproduce this, take a screenshot. That's how you get the credit. So I know you did your simulation. For example, I do a screenshot of my circuits on the right, my simulation on the right. If I saw the screenshot, I know you're good, all right? Do one filter, do one bridge. You only need to do 2, not all 5. If you want to do all 5, excellent. Spend more time, always good. But the minimum, you need to do 1 filter, 1 bridge. Okay? 1 filter and 1 bridge.
So you just want us to do the what versions of those are, what demos, what lab numbers on yours were they? Just so I can use
it will be lab 2 and lab 3 or 4. Lab 2 or lab 3 or 4. 3 or 4, you pick one.
So these files are out there on Canvas, is what you're saying?
No, you build your circuit yourself.
Yeah, no, that's what I mean. But I mean, I forgot what your first one looked like, so I was just gonna.
Oh yeah, let me go back and show. Oh, I was logged out. How can that happen? Let me show all the plots. Yes, good. Yeah, it's very slow. For some reason I was logged out. Oh, okay, finally, my circuit. So all the circuits are here. All right. Do you see every circuit? That's lab 1. You just do lab 2 and lab 3. 2 and 3.
That's all we need to make is 2 and 3.
You can pick 4 or 5. 2 or 5 or 2 or 4. Yeah. 1 filters. Those are the filters. Those 3, 4, and 5. You pick 1. And
Okay.
then you do 2. Yes. If you do it here, you can screen share your creation, and I give you credit that way. Otherwise, you can do it and take a screenshot. Okay.
Okay.
You want us to just email those screenshots to you, or are we going to turn them in on Canvas?
Yeah, turn me in on Canvas. Turn me in on Canvas.
Okay, is there an assignment created? I didn't see one when we first.
I'm still learning, so everything I will put something there. Do I need a assignment so you can turn in?
Yeah, you have to create an
Okay.
assignment. I just wanted to make
Thank
sure.
you for help. I will create an assignment. So you guys have somewhere to turn in your homework. Okay. So if you finish the lab 2, I will open the screen share for everybody to be able to share. Everybody able to share. Okay, everybody can share right now. So if you want to share, please share. And I also turn on multiple participants can share. So if 2 or 3 of you can share at the same time. And I think I will also stop my recording. So